Hey there, this is Mr. Wilford, and I just wanted to go through Chapter 6, Section 7 here with you a little bit, investigating graphs of polynomials. And what we've been talking about in this chapter, we've talked quite a bit about different kinds of polynomials, and we've been focusing more on the roots or the zeros of the polynomial, and spending a lot of time trying to find them both algebraically and a little bit graphically by factoring and so forth. What we want to do in this section really is take a look at the polynomial and the graph as a whole. And polynomial functions are classified by their degree, and so the highest power of the polynomial. We have linear functions right here. They're degree 1, so if you have x to the power of 1. We have quadratic functions, degree 2, those are x squared. We get a parabola out of there. We have cubic functions, degree 3. They look kind of like a sideways S shape. We have quartic functions, degree 4. They look like either a W, or if they're flipped around, they'll look like an M. We have quintic functions, degree 5, and this is kind of the shape they have. Basically, every time you go up a degree, you add another curve to the graph. And your graphing calculator does a nice job of handling polynomial functions and their graphs. And if we take a look here at, get to the next page here, we have something that we talk about, the end behavior. And basically the end behavior is as you move to the left and to the right side of the graph, what's happening? Is the graph going up or is it going down, basically? We have this positive infinity, so as x is going to the right forever, what's happening to the graph? Over here we have negative infinity, so as we go to the left, what's happening to the graph? Really what tells us the end behavior is the degree and the leading coefficient. And if you follow this chart, basically this is going to help you look at the end behaviors. So just quickly looking at this, if the leading coefficient is positive and you have an odd degree like 1, 3, 5 degrees, this is kind of what's going to happen on the left hand side and the right side of your graph. If you have an even degree, this is what will happen. If your leading coefficient is less than 0, so if your first coefficient, your first number is negative, then this is what will happen if it's an odd degree here or an even degree here. So referring to this table actually will help you quite a bit as you go through and you talk about the end behaviors. Now, as far as the graphing goes, these right here, this is a list of steps that you can take to graph a polynomial. However, if you have a graphing calculator, basically what you can punch in is this polynomial into the graphing calculator and it will pretty much graph it for you. Remember, there's an online graphing calculator as well that you can use, but graphing this function here, this would be a cubic function because x is cubed, and that thing would look like a sideways S when you graph that. So use your graphing calculator basically to draw the graphs of these things. And finally, we have what are called local maximum and minimum points. And this is a turning point where the graph changes from increasing to decreasing or decreasing to increasing. And we have a local maximum or minimum. And again, you can kind of use your graphing calculator to help you with many of these kinds of problems. Here's an example where we have a polynomial. This is a cubic again. And if you punch that into a graphing calculator, you see right here's the graph. You want to locate the maximum, local maximum here, and the local minimum here. And you can kind of read through this example and you can kind of tell in the first case a local maximum is approximately 17.3, and that is determined by the y coordinate of this point. And down here is a local minimum, and that is determined by the y coordinate as well, negative 5.3. If you have any questions, please let me know.